Today we have, for our first seminar for semester 2, Leon Iusitini presenting from the New Zealand, you're part of the New Zealand Work Research Institute at AUT. So Leon is a senior research fellow there. He completed his PhD on intergenerational income mobility and has been previously working as a researcher on the Pacific Island Family Study. But today he'll be talking to us about intergenerational mobility in New Zealand using the longitudinal census. So I'll just pass on to Leon now. Looks like we've got Leon in person, but unsurprisingly, with increasing COVID numbers, it looks like it's an online presentation. So we'll just have Leon up here, if that's okay. Yes.
Thank you.
Thank you so much.
Thank you, Compass folks, for the opportunity. My name's Leon, I'm from AUT. I actually first began thinking about and discussing this topic of intergenerational income mobility with Barry in 2015 or 2016, something like that. So Barry, I've returned to report back 6 years later. Okay, so that's the Stats New Zealand disclaimer. This is my work, not Stats New Zealand's. So according to a widely held narrative, New Zealand is a land of equal opportunity. An open society where everyone gets a fair go. Yet there's been a steady stream of research over decades pointing out various ways in which people's life outcomes differ by family background characteristics. You only have to look at PISA or Pearl's data or the longitudinal birth cohort studies. And so it's this apparent contradiction which motivated this study of intergenerational income mobility in New Zealand, asking the question, how closely related are people's incomes to those of their parents? And if there's a strong association, we can say intergenerational mobility is low. People's incomes are anchored quite closely to their parents' incomes. And if there's a weak association, then we can say mobility is high. And because intergenerational mobility is an indicator of equality of opportunity, albeit an imperfect one, we may be able to infer that if mobility is low, then there's widespread inequality of opportunity. And conversely, if mobility is high, there's widespread equality of opportunity. Mobility is an imperfect indicator of opportunity because some similarity between the incomes of parents and offspring can arise through just means or meritocratic processes. However, there is some empirical evidence that the two concepts are highly correlated. So the aim of this study was to estimate the degree of intergenerational income persistence, which is the inverse of mobility, between parents and their offspring in New Zealand, and to explore some of the underlying drivers of such persistence. And to do this, the study uses data from the New Zealand Longitudinal Census, which is census microdata linked at the individual level over time, spanning the 1981 to 2013 censuses. And it contains family links, so we can match offspring to parents and we can compare their incomes as reported in the census. Specifically, the study estimates persistence among father-son and mother-daughter pairs and by socio-demographic groups within these pairs. And a proxy for the permanent income or annuitized lifetime income of every individual in the sample is constructed. And in doing so, the aim is to update the very small New Zealand literature on this topic, there being only 2 previous studies of intergenerational income mobility. There have been other studies of mobility of social class, socioeconomic status, and educational attainment across generations, but just the 2 on income mobility, Andrews and Lee and Gibbons. And I'll talk later about what these studies found. So there are many concepts of and dimensions to intergenerational mobility, but the key one here is the distinction between structural mobility and exchange mobility. So structural mobility is a scalar concept referring to the change in actual income levels between parents and offspring. That is, the change in the marginal distributions of income across generations, ignoring changes in positions or ranks. And children do tend to be better off on average than their parents because of productivity gains and economic growth, even if there's no movement between the ranks of rich and poor. Exchange mobility, on the other hand, is a positional concept referring to the change in ranks between parents and offspring, ignoring changes in the marginal distributions. So ignoring economic growth or rising income inequality, for example. And the standard approach to measuring intergenerational mobility is to apply ordinary least squares to this equation, which regresses offspring's income on a constant, their parent's income, the age and age squared of both offspring and parent, and an error term, and where incomes are measured as the natural logarithm of lifetime average income or permanent income. And the slope coefficient beta is the intergenerational income elasticity, or IGE, a commonly used descriptive statistic summarizing the association between offspring's and parents' incomes. And because incomes are measured in logs, differences in log income approximate percentage differences in income. So the IGE measures the percentage change in offspring's long-run income associated with the percentage change in parental long-run income. The IGE measures income persistence. So 1 minus the IGE is a measure of mobility or the rate of regression to the mean. A high IGE implies high persistence of incomes across generations, i.e. low mobility, and a low IGE means low persistence of incomes across generations or high mobility. Empirically, the IGE is typically found to lie between 0 and 1, where 0 means no relationship between parents and offspring's incomes, and 1 means there's a perfect dependence between the two. The IGE captures the total relationship between parents and offspring's incomes. It's not a causal parameter. The IGE is not given a causal interpretation, but rather reflects the influence on offspring's income of all factors correlated with parental income. It's basically a catch-all measure of economic advantage. And importantly, the IGE captures both changes in the marginal distributions and changes in ranks. In other words, it doesn't distinguish between structural and exchange mobility. It captures both aspects. So the ideal scenario for measuring intergenerational mobility would be where you have complete lifetime income histories for 2 generations. But of course, such data sets are rare. Some of the Scandinavian countries do have this or close to it, but usually researchers are stuck with short-run proxies, short-run measures of income to proxy for unobserved lifetime income. And this makes estimating intergenerational mobility a challenging task because it introduces measurement error, which can bias estimates of intergenerational persistence. And there are 3 main types of measurement error. You can measure incomes over too short a period. And if you do that in the parent generation, then your IGE can be biased downwards, understating persistence and overstating mobility. This is the classical errors and variables attenuation bias. In theory, attenuation bias doesn't apply on the left-hand side for offspring income, but there is empirical evidence that using too short a measure of income on the left-hand side can also bias IGE estimates. Secondly, you could measure incomes at too young an age or too old an age, so-called lifecycle bias, which can also bias estimates of the IGE in the directions shown here. These are ages at which differences in current income are not reliable guides to differences in permanent income. So one suggested solution for attenuation bias is to take an average of income over many years. Studies suggest at least 10 years. And even better if you can take an average over non-consecutive years, years spaced apart, as in the census, which are all at least 5 years apart, because you get better smoothing out of noise. Another solution is to use instrumental variables, but I don't do that. And for life cycle bias, one solution is to measure income at an age when current income best approximates lifetime average income. And the empirical evidence from other countries, to my knowledge, there's no New Zealand specific evidence, but the evidence from other countries suggests income between the mid-30s and early 40s for men, fathers and sons, and between 40 to 50 years for women, mothers and daughters, is reasonably representative of lifetime average income. So moving on to the data source, the longitudinal census links people's census records through time. This is microdata in the data lab, but it's not part of the IDI. So each census is linked backwards to the previous census, creating 6 census pairs, the 6 arrows shown here. And because each pair has a common boundary with another, people can be linked across up to 7 censuses, i.e. from 2013 right back to 1981, a 32-year time span. A person can be linked across censuses if at the earlier census they had been born and filled out a census form and resided in New Zealand. If you're overseas during a census, you can't be linked back over the period you were away. And here are the link rates for each census pair. So you can see that across all census pairs, the average link rate is about 70%. That is about 70% of eligible people who in theory are linkable, are able to be linked back to the previous census. And naturally, the link rate falls as the time span increases, such that only 32% of people are linked from 2006 right back to 1981. The link rate from 2013 back to 1981 hasn't been published, I don't think, but it'll be lower than 32%. Linking was largely deterministic. So of that 70% average link rate, about 67% was from deterministic linking based on exact and unique matches for sex, date of birth, and area of usual residence. And country of birth and Māori descent were also used where necessary. Names and exact addresses were not available for linking. And then the remaining 3% was from probabilistic linking. This is where there isn't an exact match, so records are compared on how closely they match. And if the probability they're a true match exceeds a certain cutoff, then they're deemed to be a true match. So groups who are less likely to be linked include young adults, especially those in their 20s, men, Māori, Pacific and Asian, people living in more deprived areas, and people who are more residentially mobile, people who changed address since the last census, and people who rent. And by virtue of the way the longitudinal census is constructed, immigrants, people who leave New Zealand, cannot be linked if they miss a census while they're away. So the data set effectively excludes immigrants, or at least it excludes people who leave New Zealand for the medium to long term. Shorter stints overseas during an intercensal period won't affect your linkage, provided you return to New Zealand in time for the next census. So all of this potentially introduces selection bias by what you might call differential attrition, i.e. certain groups, many that are probably lower income groups on average, are more likely to drop out of the longitudinal census. And it's hard to know for sure what effect this might have on estimates of intergenerational persistence, but it may bias it downwards if persistence is stronger among these groups. So I start with identifying families from the 1981 census so that the offspring in those families can be observed in the later censuses, 2006 and 2013, in the right age ranges from mid-30s up. So that's where the sample of offspring is drawn from the 1981 census. That census defined a family as, quote, a husband and wife with or without never married children of any age, or a lone parent with one or more never married children living in a private household. The term children includes stepchildren and adopted children, but not foster children. A family is not necessarily all related people in a household, but only those related by blood, marriage, or adoption who normally live together as a single family unit and who are present on census night. So I've highlighted a few important bits here. Firstly, children can be step or adopted children, which means the fathers and mothers in this analysis could be step or adoptive parents. They're not all birth parents. And secondly, you had to be home on census night to be counted or enumerated in your family. So if you didn't fill out a census form, you weren't enumerated in your family. Or if you filled out a census form from somewhere other than your home on census night 1981, you weren't repatriated or put back into your family, as it were. The census contains variables for family ID number and role in family, which together enable linking of fathers with their sons and mothers with their daughters. This analysis uses the father and mother enumerated in 1981 and sticks with those parents. Any changes to the parental figures over time are disregarded. Only the 1981 parents are used. And fathers and mothers may have multiple sons and daughters in the 1981 census. Therefore, there are siblings, brothers and sisters, in the samples. So each census asks people to report their total personal income, which is gross annual income from all sources over the previous 12 months. So it includes social welfare benefits. It's collected in bands. So in this analysis, parents and offspring are assigned the median of their band, calculated by Stats New Zealand from more granular survey data, usually the Household Economic Survey. And this includes medians for the open-ended top categories, except for 1981 when midpoints were used. And then these band medians are deflated to September 2012 dollars using the Consumer Price Index. And then a time average is taken of the total personal income variable over several censuses as a proxy for an individual's permanent income. So in the case of parents, an average is taken over 2 to 7 censuses. In the case of offspring, over 1 to 5 censuses. So offspring can have a single observation as their proxy, but not parents. And these time averages are always centered around age 35 for fathers and sons and age 40 for mothers and daughters. So for men, for example, the middle observation is in the mid-30s with observations either side of it, so that the averages are always centered around the mid-30s. So the time averaging is meant to deal with attenuation bias, and the centering of the average around a particular age is meant to deal with lifecycle bias. So to be eligible for inclusion in the analysis, both offspring and parents have to be in the right age range so that proxying their permanent income is possible. So for sons and their fathers, that means being observable in your mid-30s. So the analysis focuses on sons aged 2 to 14 in 1981, born 1967 to 1979, because they can be observed in their mid-30s in the later censuses, provided they're linked through that far and have non-missing income data. That's the age they need to be to get a good proxy for their permanent income. So if you're aged 1 in 1981, for example, then by 2013, you're 33 years old, which is slightly too young for this analysis, not quite mid-30s. So it's got to be 2 to 14 in 1981. And then I look at the fathers of those sons in 1981 and see which of the fathers can be observed in their mid-30s in the earlier censuses. And it's the ones who are aged 19 to 33 in 1981, born 1948 to 1962, for whom a proxy centered on age 35 could be constructed. This does restrict the age range of fathers. Older fathers are excluded. But I do run a robustness check in which this age restriction is relaxed. So this is how the target population is defined. If a son is in the right age bracket for proxying his permanent income and he can be matched to a father who is 2, then that father-son pair is eligible for the analysis. And analogously, this is how the population of daughters and mothers is defined. If daughters are born between 1967 and 1974, and therefore aged 7 to 14 in 1981, and their mothers are born between 1943 and 1958, and aged 23 to 38 in 1981, then those mother-daughter pairs are eligible for the analysis because both can be observed in the right age range, at the right age bracket around age 40 for proxying their permanent income. And so the target populations are sons and daughters who were in the right age range in 1981, who could be matched to their father or mother who was also in the right age range. And these numbered 57,000 father-son pairs and 86,000 mother-daughter pairs. And then the samples are the subset for whom a proxy for permanent income could actually be constructed for both the offspring and their parent, which means not only were they in the right age bracket, but they were also linked far enough through the longitudinal census and had non-missing income data. And these numbered 4,617 father-son pairs and 9,312 mother-daughter pairs. So the samples are broadly representative of the populations across a range of socio-demographic characteristics, with the exception of ethnicity and family type. Sons and daughters who are European and from 2-parent families are overrepresented in the samples. Sons and daughters of non-European ethnicities and from single-parent families are underrepresented. And again, potentially introducing selection bias if intergenerational persistence systematically differs between these groups. So here's the permanent income proxies constructed for the father-son sample. On the left, we have a kernel density plot of log permanent income, sons in orange, fathers in blue, showing a slightly more condensed distribution of permanent income for fathers than for sons, and little income gain across generations. You can see from the statistics there, the statistics are in levels, but the graph is in logs. You can see that sons and fathers have similar central tendencies. In fact, sons' median income is lower than fathers. And on the right, we have a scatter plot of sons versus fathers' log permanent income with a prediction line fitted with linear regression in black and a low S curve in blue. Low S locally weighted scatter plot smoothing, which helps to visualize any non-linearity in the relationship. And you can see that there is a positive relationship between fathers and sons' incomes, and the low S curve suggests the relationship is pretty linear. The curve doesn't stray much from the linear line of best fit. And you can also see there are a handful of sons, less than 1% of the sample, who have log permanent income of 0. That's the dots at the bottom there. And these are sons who reported 0 income in the census, which was recoded to $1, which when logged is 0. And this was done in order to retain these sons in the sample, but I run a robustness check in which these sons are dropped instead. And then here we have the same for mother-daughter pairs. And we can see the daughter's distribution is shifted to the right, reflecting intergenerational gains relative to their mothers, although daughters have a larger probability mass at 0 income. And again, a positive relationship, albeit with some outliers who have log income of 0. And the low S curve is in line with the linear line through the great mass of the distribution. It's just the outliers that pull the low S curve away from linearity. And here are the results. So regressing sons' log permanent income on father's log permanent income and the age controls gives an IgE, or elasticity, of 0.239. That means a 10% increase in father's long-run income is associated with, on average, a 2.39% increase in son's long-run income. And regressing daughter's log permanent income on mother's log permanent income and the age controls gives an IgE of 0.145. So a 10% increase in mother's long-run income is associated with a 1.45% increase in daughter's long-run income. Here I compare these estimates to those from studies of other countries, plus 2 other estimates for New Zealand. These are all father-son elasticities that use total income, just as in the census, or failing that labor earnings. So the ones with wide confidence intervals use survey data. The ones with tiny confidence intervals use admin data. So starting on the left, we've got the longitudinal census estimate that I just mentioned. Then we've got estimates for Australia and Denmark. Then 2 previous estimates for New Zealand. The first from Andrews and Lee, who used data from the 1999 International Social Survey Program, and they regress sons' log hourly wages on fathers' imputed log hourly wages, predicted based on father's occupation, and they get an IgE of 0.245. And then the second from Gibbons, who uses data from the longitudinal Dunedin study, and he regresses sons' log total income at age 32 on father's log total income and gets an IgE of 0.253. So they're both fairly similar to the census estimate. And then we have estimates for Sweden, Finland, Germany, Norway, Canada, Italy, Great Britain, and the US. And this country ranking is pretty much a stylized fact. Britain and the US having relatively high persistence, the Nordic countries having relatively low persistence, Canada somewhere in between. So on these estimates, New Zealand has comparatively low persistence, i.e. high mobility by international standards. For mother-daughter pairs, New Zealand has higher persistence than Finland, Sweden, and Australia, which are the only countries for which there are available estimates for mother-daughter pairs. So clearly the confidence intervals on the census estimates are quite wide. And because of a myriad of sample selection and other data-related differences across studies, a precise ranking of countries is fraught with difficulty. So a chart like this needs to be interpreted with caution. Now, because the IgE may conceal heterogeneity between groups, I estimate group-specific elasticities. Hertz points out that simply stratifying the sample and estimating the IgE separately for each group will produce a misleading comparison of persistence between groups because, quote, any long-run difference in group income means is ignored under stratification, and this can lead to the false impression that a persistently disadvantaged group is actually highly mobile. Children of the disadvantaged group may be quite mobile with respect to their parents when measured by their within-group intergenerational elasticity, but if both parents and children in that group are generally confined to the lower end of the income distribution, then the children will typically remain relatively disadvantaged, which is to say they will display little mobility. So Hertz develops a group-specific IgE statistic, which measures both the degree to which parents and children have similar incomes within a group, as well as the degree to which people in a given group tend to fall above or below the sample mean, i.e. the average income pooled across all groups. And so Hertz uses this formula, which makes use of the sample size shares of each group, the sample mean and variance of income for the whole sample, the sample mean and variance for each specific group, and the within group elasticities. And so using all that information, we can estimate for each group a group specific elasticity, which is made up of a within group component, the degree to which parents and offspring have similar incomes within a group, and a between group component, the degree to which people in a given group tend to fall above or below the average income. And so starting with father-son pairs, the first panel shows the sample split by son's ethnicity. The second panel shows the sample by whether the father was a Social Security beneficiary in 1981. And the third panel shows the sample by father's education level. And then we have the group-specific elasticities plotted, and the dashed line shows the overall elasticity for comparison. And so we can see minimal ethnic differences between European only, Māori only, and all other sons. Although when the definition of Māori is changed from solely Māori to any Māori, that is all sons with any Māori heritage, the estimate increases to 0.314, higher than European. The other interesting results here are the very high estimates of persistence among sons whose fathers were beneficiaries in 1981, which represents the intergenerational transmission of relatively low incomes, transmission of disadvantage, and the high persistence among sons of degree qualified fathers, intergenerational transmission of relatively high incomes of advantage, illustrating the sort of heterogeneity that exists within the population. The picture is a little different among mother-daughter pairs. There are generally minimal group differences, and the differences that stand out run in the opposite direction to father-son pairs. Namely, persistence is lower than average among daughters of beneficiaries and daughters of degree qualified mothers. I'm not entirely sure why this is, but I suspect it's related to increasing labor force participation of women over time, which has meant daughters have been better able to realize their earnings potential than their mothers were. And consequently, the association between mothers and daughters' incomes has loosened, perhaps especially for highly educated mothers whose earnings capacity may have gone particularly unrealized. And then finally, I explore some of the mechanisms by which parents with more income produce higher earning offspring, the channels through which parents' income influences their offspring's income. And I do this with a decomposition method that decomposes the intergenerational income association into pathways that mediate that relationship. So the method decomposes the IgE estimate into a component transmitted through a pathway factor, some characteristic of the offspring like their educational attainment, and a component not transmitted through that pathway. So the first component, the part transmitted through the pathway, is the product of the strength of the relationship between parental income and the offspring characteristic. That's the red arrow here, lambda. And the income payoff of the characteristic to the offspring in the labor market, the yellow arrow, rho. And then the bit not mediated by the characteristic is gamma. And so we can decompose persistence into a component accounted for by the pathway, lambda times rho, and a component not accounted for by the pathway, gamma. And it's a simple matter to extend this to multiple pathways, where the pathways are typically added sequentially in roughly the chronological order that they occur in the life course. Now, the key identifying assumption here is that there are no unobserved factors that are correlated with parental income and that influence the transmission mechanism. But of course, this is a strong assumption that's unlikely to be met in reality, because omitted parental characteristics like parents' education will be correlated with parents' income and have an effect on the pathway, the offspring characteristic. So the pathway's mediating effect is likely to be overstated because it's channeling a range of parental characteristics, not just parental income. And furthermore, the results of the decomposition depend on how many pathway variables you add and in what order. So this is not a causal exercise. It's a descriptive exercise that provides suggestive evidence about likely mechanisms at play. Now, the census collects very few variables that could sensibly be considered transmission mechanisms for intergenerational persistence. So I'm basically restricted to offspring's educational attainment and occupational attainment. So what we have here is the percentage of the IGE accounted for by those two pathway variables. So starting with father-son pairs, in model 1 here, I only consider educational attainment, defined as son's highest qualification attained by their mid-30s. And you can see that highest qualification accounts for just under half of income persistence from fathers to sons. In model 2, I consider occupation by itself. This is son's occupation in his mid-30s as ranked by skill level according to the New Zealand Standard Classification of Occupations. And you can see that it accounts for just under a third of persistence from fathers to sons. And then in model 3, I consider the two pathways jointly, adding education first. And together they account for about half of persistence. And comparing model 1 with model 3, the addition of occupation doesn't add all that much to the overall amount of persistence explained, suggesting that occupation is largely channeling the effects of educational attainment. Among mother-daughter pairs, it's a very different story. Education and occupation account for much smaller proportions of persistence, together accounting for a third of persistence. One difference from father-son pairs is that occupation plays a larger role relative to education among mother-daughter pairs, whereas education is the more important mechanism among father-son pairs. So summing up, the longitudinal census has considerable limitations for a study of intergenerational mobility. The income is self-reported and banded. There's attrition and it differs by groups. Immigrants are excluded and so on. Nevertheless, the results suggest that income persistence from fathers to sons in New Zealand is relatively low, mobility relatively high by international comparison, and from mothers to daughters is relatively high, mobility low, at least among the particular cohorts studied. And I emphasize that because mobility can change over time. This isn't written in stone. Some scholars like Brian Easton have argued that mobility is likely to be a lot different for cohorts born since 1990. And I think Max Rashbrook makes a similar argument. There's heterogeneity in persistence among subgroups in the population, notably by parental education level, although this differs between men and women. Offspring's educational attainment and occupation play important roles in channeling persistence from parent to offspring, although much more so from fathers to sons than from mothers to daughters. And in future, it would be useful to distinguish structural and exchange mobility. I did try to estimate rank mobility, so looking just at changes in ranks across generations, but the census data wasn't very amenable to it. My derived permanent income variable had quite a lot of bunching or clumping in parts of the distribution because of the banding. And consequently, the distribution wouldn't divide neatly into quantiles I tried deciles, quintiles, quartiles, but with not much luck. It would also be useful to explore a wider set of mechanisms beyond education and occupation, depending what else is available in the census. And it would be useful to estimate mobility with administrative data. I think by now the inland revenue income data in the IDI spans 23 years, which may be sufficiently long to estimate mobility for some cohorts. But in any case, it'll become increasingly feasible in the coming years to study this topic in the IDI. I mentioned robustness checks, but I didn't show them because of time constraints, but I do have those on extra slides if needed. Thank you very much.
Thank you. Martin, did you want to field the questions through?
Yeah, I'll just sort of read over what's been in there. The first question, Ryan asked, interested in whether you estimated IGE for daughters on fathers' income and sons on mothers. So basically, you clearly made a decision to do the ones you did.
Yeah, I did do that. I did father, daughter, and mother, son as well. I haven't reported them here because of time and space, but yeah, it's tricky when comparing the sexes because of differences between the sexes and labour force participation and so on. It gets very tricky to sort of interpret. But I do have estimates for those pairs. Yeah, I haven't got them on the slideshow here, but they are in my thesis, which is online.
Okay, cool. Barry says, great talk, Leon. Benefits. Fathers and mothers likely received quite different benefits. Fathers may have been dominated by unemployment benefit, where mothers dominated by sole parent benefit. Might your results suggest that mothers getting the DPB gives their daughters a good chance to succeed?
Yes. Yes, it's a tricky one to know the mechanism there, but yeah, it's consistent with that. Yeah, I'd have to look into that in more detail. It's an interesting speculation.
Also, knowing the machinations of the census data and the longitudinal census, even just the comparability of the benefit variables over time is pretty sketchy, isn't it? Because they continuously change the way that they collected them in the census from between different groups, and of course the benefits were changing over that period as well. It was really, from my perspective, it was really interesting to hear of your use of longitudinal census data, because I did a lot of work on that earlier and trying to use it more recently, and it's sort of been superseded by IDI stuff. So it's good to hear that that's still being drilled for results. The next one, Alice Kim, powerful and important results. I can see a lot of thought went into the study design and analysis plan. Be interested to find out how you accounted for discounting for time and regression towards the mean for parent-child income, if that's relevant. Carl Pike.
Yeah, discounting. Yeah, I didn't discount the income data. Some researchers do that. Possibly I should have. But it's deflated but not discounted. But I can look into that.
Okay, and Comey says, important findings. I recently read that perceptions of income inequality in general tend to not match actual disparities, so it's good to see data clarified like this. The gender difference is intriguing, and asking for a copy of your report, which I guess is still just as your thesis. And are you publishing further from that now? Yeah, that's in progress at the moment. Hopefully get something out this year, journal article. Cool. Bradley Drayton, thank you for a really nice presentation. Would you like to comment on what might be happening among cohorts born in the 80s and 90s? Yeah, well, I don't know. We don't have, we might, the IDI, we might have, it may be possible to estimate for some cohorts born in the 80s and 90s.
I mean, who knows? I mean, you know, as I mentioned, people like Brian Easton argue that mobility is likely to be lower, persistence higher for cohorts born, well, he's talking about born since 1990, yeah, I mean, that's research that needs to be done. That's the next step.
Yeah, unfortunately, it's not likely that they'll continue working on the longitudinal census so much when they're putting the individual censuses in the IDI. So maybe historical, it's not going to be so easy. But as you say, with the IDI, some of the IDI data stretching back as far.
Are they not putting any more censuses into the longitudinal census?
No, I don't think they're continuing the longitudinal census. I think they're continuing it in the IDI. Barry says read the IDI, there should be good parent-child links for children born since 1984 using DIA records.
So I think they are still linking the longitudinal census, even with 2018. They're giving.
Okay. Obviously, the numbers of people linked are going to get so small eventually.
Yeah.
I think there's I think Ryan was asking, do you have ballpark estimates for the IGAs for the mother, son, and father, daughters on hand?
Oh man, you're putting me on the spot. No, sorry.
We'll have to watch this, return to this space.
Yeah, if you email me, I'll flick it through.
Cool. I found the thesis online, he says. Okay, great.
Excellent.
Barry's saying your R-squareds are quite low. Are they in line with international estimates?
I don't know the answer to that. I didn't compare the R-squareds. I'd have to look into that, sorry.
Okay. Have you considered treating these samples as complex samples and using weight adjustment techniques to address the sampling issues?
No. My understanding is that maybe someone from Compass did derive some weights that can be used with the longitudinal census. I didn't go down that route, but partly because I could be wrong here, but I assume that I need sort of sample specific weights that sort of relate specifically to my sample and the bias in my sample or potential bias. So no, I didn't go down that track, and I'm not sure if weights are currently available in the longitudinal census dataset. Does anyone know?
We have, yeah, I mean, we had, I think, a summer student and or maybe a couple and maybe a thesis worked on doing those bias weights. Unfortunately, they only go to 2006 at this time as well. So it would have been, I think we were thinking about recently trying to get them through to 2013. But the format of the Stats New Zealand data changed with 2013 edition as well, I recall. And some things were made more difficult to work with. But they have, I'm not sure about the specific sample weights, but they were done for sort of working with different periods, sort of geometric mean weights across different numbers of periods. The last time I was using them, I ended up having to not use weights overall because we were including 2013 in it. So it right. It is obviously, yeah, becomes quite sort of tricky at that point. Is the linking algorithm used in the longitudinal census the same as algorithms used in the IDI?
No, I mean, I'm not sure. I'm not sure what was used in the IDI, and I don't know how it compares with the longitudinal census. Does anyone
probably jump in there?
Yep.
In a sense, completely different. With the longitudinal census, they're linking back to always pairwise links to the person in the previous census. With the IDI, they formed a spine of births, tax records, and immigration records, and linked all the data sets to that. In terms of the linking procedure afterwards, it was relatively similar, using the Filigi-Sunter weights and the quality stage methods, mix of deterministic and probabilistic. But You'd have to look this up, but I think they may have been able to use more information with the IDI than with the longitudinal census.
I have a feeling that also, because linking to with the 2013 coming into the longitudinal census, they had relied quite heavily on the question of where did you live 5 years ago, matching.
That's a good point.
Censuses.
Yeah. So
And
there was one thing that they used that got screwed up with 2013. They
Yeah.
kept the question the same when they delayed the census. So the question still was, where did you live 5 years ago, which isn't a good indicator of where you were, which was 2008, or a good indicator of where you were at the 2006 census.
Yeah. Having said that, I think that when we talked to them at one point, they suggested that there were, for the first time, they were able to access electronic like name and address records to improve the matching for 2013 as a result with the longitudinal census. I think that's something they did.
Thanks for the clarification, Barry, and thanks for the great talk, Leon. The linking algorithm question was from me. The reason I asked this was because in one of your earlier slides, it says that most of the records were deterministically linked, and only 3% of those were probabilistically linked. And I don't think that's the, well, it's definitely not the case for the IDI. In the IDI, most of the records were probabilistically linked. So yeah, just on that, I had this question.
Barry, do you know why the discrepancy between probabilistic in the census and IDI?
I think Martin may have caught on to it. They mostly relied on, were you living at the same place 5 years ago?
Yeah.
Whereas with the IDI, and Eileen would know this better, they used a soundex of the last name, first name, date of birth, Māori descent, a few other bits and pieces, and then got a weight. And they also had what they called near exact and non-exact links. And so while they weren't deterministic, they were kind of near exact with a little bit of elasticity for particular fields such as month of birth or day of birth or something like that. So they went straight forward and did most of them probabilistically, I think. And the deal is there, the higher the weight, the greater likelihood it is that it's a true match. There's a team at IDI you can talk to about it if anyone is interested.
Yeah, of course, the census period being constant for as long as it was did mean that 5 year 5 year thing, when they talk about deterministic, it's still relying on people sort of remembering how long they've been places. And as then Barry said very early on when we were working with the longitudinal census about, as you said, the groups that are going to be undercovered because people in their 20s are moving around a lot more, and there would even be discrepancies in remembering where you were 5 years ago. There would also be potential people, getting the mail to their previous address and issues like that with those data. So it was a really interesting thing to use as a constant measure, but laden with issues. And as you talked about with immigrants and anyone having left, like if you left, came back to the same address within 5 years, you were fine. But anything else, it's a bit of a worry. I think that's fielded everything from the online. There's just a couple of other requests to see the publication. So if Ryan's found that online, we'll just send out a link to our to sort of the people that are on our mailing list when I advertise the next seminar next week. I guess I'll hand back to Steph if she has any questions, and then we'll wrap this up.
And I think
Thank you again. It's been great.
Yeah, thank you so much. Thanks, Martin, for fielding the questions as well, and thanks everyone for attending.